All right. So we're going to group these down the middle. Now, I gave you a guide. Oh, I gave you a guide, and on that guide, I tried to walk you through how to factor. Okay. Um, this is certainly not my first rodeo. I know that factoring tends to be a struggle for people, and part of it is just knowing where to start and what to look for. The one thing you must always do is first check to see if there's anything common to all of them, especially as it relates to these letters and numbers. Because as you look at it, the 3 is common to 3 of them, but it's not common to all 4, so that doesn't help. The R is common to a lot of them, but not all of them, so that doesn't help. Does that make sense? And so as you do this, if there's nothing common to all of them, the next thing to figure out is how many terms do we have? It's either going to be 2, 3, or 4. Somebody asked me one time, what if there's 6? Shit, pray. All right? If there's 6, just pray, because that's going to be harder for you. But if there's only 4, we're going to do it by grouping. What's common to the first 2? That would be an R. So we take the R out. We get R minus 3T. What's common to the next one? 3W. If we take out the 3W, we get R minus 3T. Once we do that, we should recognize, if we do it correctly, the 2 parentheses ought to be the same. Now, will they always be the same? No, but if they're not, one of us made a mistake. There's a chance it's me. I'm not going to lie because I've done it before. But there's also a chance it's you as well. R minus 3T. R plus 3W. And that is the factored form. Okay. Yes. If you put 3T minus R, then the other parenthesis has to be negative R minus 3W. If you put 3T minus R, then that is wrong, yes. Sometimes you can have some variations in the minuses, but in this case, that would be wrong, yes. Yes, that would be okay. That's the commutative property of addition. Okay. X to the 4th minus 81. Now you saw one similar to that earlier today. It was x to the 4th minus 16. So x to the 4th minus 81 is x squared plus 9 and x squared minus 9. Now, when you get a parenthesis that has an x squared, when you get a parenthesis that has an x squared, when you get a parenthesis that has an x squared in it, you always have to be careful with that. Because there's a, I'm going to say 50-50. And by 50-50, I mean I'm completely making up that crap. All right? But there's a 50-50 chance that when you get x squared, it's going to continue. So that needs to be some kind of red flag for you. Like, hey, it's x squared. It might continue. All right? This does, in fact, continue. It's x squared plus 9, and then this one is x plus 3, x minus 3. Legitimately, this is what I know about students, though. Most students, not all, but most, want to work problems based on ones they've seen similar to that. Okay, and there's nothing wrong with that, by the way. I mean, this is not like a condemnation of everything wrong with students. It's not that at all. But what happens to a lot of people is when they see a problem like this and they get x squared plus 9 oh shit. Now I'm so damn pissed off. And then they see that this continues, then they want to do that for every problem they see. I mean, that's what a lot of students go like this. Well, shit, it continues. And so then if I give you this, x to the fourth minus, let's say 100, for example. Well, what is that? X squared plus 10, x squared minus 10. Now the question is, can you continue? No. So it cannot just be I see a problem that works one way, and now every time I see a problem that has similar numbers, I do it the same way every time. It's not that. See, that works in solving, right? In solving equations, if you had 8x equals 16, you divide by 8, divide by 8. No matter what you see when the problem looks like that, that's the way you're going to do it. Factoring doesn't work that way. This one doesn't continue, right? If I say to you, x squared minus 81, and you get x plus 9, x minus 9. This doesn't continue, even though the 9 is a perfect square now. Because this one is not. Does that make sense? And I feel like I'm harping on something that maybe some of you are going, shit, I got that dry. I don't need that part. No, it's very important because sometimes it does and sometimes it doesn't. And I don't give partial credit. And we can talk about the merits of whether we should or should not give partial credit. But guess what? You're arguing with the person who's not going to give it to you. Is that fair? You know, it's like complaining about playing time. Well, go argue to the person who's not giving it to you and see how that works out for you. Okay? I think I deserve it. Well, I don't think you do. I guess you ain't playing. Okay?
So does the x squared minus 4, is that okay if it would the final answer to be x squared plus 4, x plus 2, x minus 2?
That would be the final answer. X squared plus 4, and then x squared plus, or x plus 2. X plus 2, x minus 2. That is your final answer, and only that will be acceptable. Now, you could adjust, you could put the x squared plus 4 on the end if you wanted to, but it's got to look like that. Okay? Got to look like that. So I guess we'll just pretend that we didn't write over here. Oh, great. This is lovely. Oh, lovely. I swear to God, this system is so... We're going to take a station identification. We're back. This is the difference of two cubes. So on that factoring guide I gave you, after I said put them in order, after I said take out anything common, we then identify how many terms we have. We know if we have 4 terms, that's factored by grouping. If I have 2 terms, I'm either going to be dealing with squares or I'm going to be dealing with cubes. It's cubes if it's divisible by 3. It's squares if it's divisible by 2. Let me say that again, because I know some people didn't hear it. It's cubed if it's divisible by 3. It's square if it's divisible by 2. These are cubes. So this is z and 5p. Those are the 2 pieces that make up that perfect cube. I say that because z times z times z is z cubed, and 5p times 5p times 5p is 125p cubed. So we're dealing with these 2 pieces. So the formula is this. It's small parenthesis, big parenthesis. Small, big. Z minus 5p z squared plus 5pz plus 25p squared. Now, where did those pieces come from? Because it seems like I just made them up. It's what times what times what gives me these pieces. That's where I got this and this from. These pieces immediately go in. That becomes the small parentheses. Then it's z times z is z squared. 5p times 5p is 25p cubed, or p squared. So 5p times 5p is 25p squared. Z times z is z squared. The middle term, you must switch this sign. These two have to be opposite. This one and this one have to be different. If it's not, you're guaranteed to be wrong.
No matter which one the different in.
Well, yeah, it does matter because this one here has to be the same as the problem. Okay? Because if not, you won't get, when you do negative times this, you got to get a negative number. So that's why. All right. And then multiply these two together. Z times 5p gives me the 5pz. Okay. What's wrong, dude?
So what's the answer?
This.
Oh. Okay.
The final answer would look like this. Does that make sense? I mean, the other strip was so clustered you wouldn't be able to see it, but that's the final answer. Okay. For this, I mean, it's a good point. I'm glad you said something. I'm going to write up the final answer and now I'll explain it to you, okay? So that everybody knows what the final answer you're supposed to write down is. It's 3y squared plus z squared 9y to the fourth minus 3y squared z squared plus z to the fourth. That is your final answer. Now let's go over how we got that. 27y to the 6. That is 3y squared times 3y squared times 3y squared. Okay. Z to the 6 is z to the second times z to the second times z to the second. Okay. Now, it's going to be small parenthesis, big parenthesis. These two pieces go into the small parenthesis just the way they are. 3y squared, z squared. This sign here is the same as this sign here. Now, multiply it times itself. 3y squared times 3y squared is 9y to the fourth. That is 3y squared times 3y squared. Multiply this by itself. Z squared times z squared is z to the fourth. Okay, the last sign's always positive. Multiply these two times each other, you'll get 3y squared z squared. That's a y, not an x. Switch the signs so they're different. Okay. And here's the thing. There are things that I think you need to kind of understand where they come from. And then there are things that I think you just need to kind of memorize. Okay? This is one of those things that you just have to kind of memorize. That all of the ones that are cubes follow a set pattern, and then you just have to memorize the pattern. Okay. All right. Looking at 4, 5, and 6. Here we go. What number is common to number 5? What number goes into all three? 3. So we're going to take out the 3. When we take out the 3, we get 8x squared minus 2x minus 3. Okay, yes. Now, if the 8x squared minus 2x minus 3 does not factor anymore, then that's the answer that you put in the blank. If 8x squared minus 2x minus 3 does not factor anymore, then that would be the answer you put in the blank, because you technically have factored it. Now, if it's a trinomial, and by trinomial I mean it has 3 terms. If it's a trinomial, if it factors, it will do so in this fashion. Now, what you must do is, first of all, figure out what signs go here and here. What signs are going to go in the middle here? It's going to be a positive and a negative. Now, when I say it's going to be a positive and a negative, let's be honest. It could be a negative and a positive. I don't know. I just know that they have to be different. And the fact of the matter is, I just put positive and negative every single time. And then if it's not right, I'll fix it. Okay? Now, here's where students sometimes struggle. How do you know if it's not right? Because people are going like this. Well, I don't know it's not right until you damn grade it and give it back to me. And then I look at it and go like this. That wasn't right. How do you know if it's not right? Well, the way you can tell is this 3, the only options for 3 are 1 and 3. I think we all agree on that. And what are the options for 8x squared? 4x and 2x, right? Now, what I said to you was, don't put common factors side by side. You remember that? We had a whole discussion last time about not putting common factors side by side. In this case, we don't get lucky in that sense that we have a common factor issue to deal with. So all we have to do now is just check. 1 times 2x is 2x. 4x times negative 3 is negative 12x. And this is negative 10x. What I need you to understand, some of you have more than one key on your key ring. And you've had to go to a master lock and you just try like 3 or 4 of them until you find the one that is. In your world, you're going like this. I know one of these is right. And then you try one and you go like this. Well, that one didn't work. It's just very similar. You try it and you go like this. Didn't work. So you try a different one. Switch to 3. Make this a 3. Make this a 1. So now what do you get? So you get 6x is the middle. Negative 4x is the outside. What does that give you? 2x. Now what do you want? Negative 2x. Anytime you get the right answer but the wrong sign, all you got to do is just go in and switch those signs. Anytime you get the right answer but the wrong sign, just go back and switch the signs around. Okay? Now, 15x squared plus 14x minus 8. Anything common to all 3? No. So we go here. This last sign is minus. So these 2 signs are going to be different. Due to time constraints, I'm going to make them negative and positive, as opposed to my customary positive and negative that I always do. Okay? Now, some of you are going like this. Well, I think he knows something. Maybe I do. We'll see. What gives me 15x squared? 5x, and 3x. As I've talked to you before, I don't know how many of you play chess, but if you play chess, you might know the importance of thinking ahead a little bit. I'm going to think ahead a little bit, and I'm going to put the 4 here and the 2 here. And now I'm going to check it. 5x times 4 is 20x. Negative 2 times 3x is negative 6x. That gives you 14x. We got lucky. All right. It was part of that secret society class I took. All right. Any questions on that? Nothing common. Last sign's minus. We'll do, what gives me 12x squared? 4x and 3x. What gives me 2? 1 and 2, right? Notice you cannot put the 2 here as that's a common factor, and that would be a problem. Does everybody see what I'm saying? 2's got to go here. 1's got to go here. Negative 8x plus 3x is negative 5x. If somebody bothering you, Silvernus, because I'll go out there and give them absolute heck. Now, you good? Okay. Is negative 5x the right answer? No. Change the signs. Now, bottom line. This process is long, and it ain't all that much fun. I'll be honest about it. Get the right answer is a hell of a lot of fun, though. Okay? And this is the best way to do it. Now, again, are there other techniques? Look, come see me in the morning. I'll show you all kinds of damn techniques. I'm telling you, there's slip and slide, and there's California, and there's South Dakota, and I mean, there's just all kinds of crazy-ass ways to do it. This is the way I'm showing it for purposes of our discussion. All right? With that being said, we're going to stop the video there. I'm not done, though. We're just going to stop the video. We're stuck.